Problem number 10. Positive integer numbers m and n are such that 3 to the power of m minus 2 to the power of n is divisible by 47. What could be the remainder of the division of 4m plus n by 23? We'll start with the notation. So a equals b mod n means that a can be expressed as a sum of k times n and b, where b is the remainder here and k is an integer number. So let's try some combinations of powers to better understand the task, and we need such combinations of m and n such that 3 to the power of m minus 2 to the power of n is divisible by 47. Okay, m equals to 5 and n equals 3. Will give us 3 to the power of 5 minus 2 to the power of 3 is equal to 243 minus 8, that is equal to 235, which can be expressed as 47 multiplied by 5, which is obviously divisible by 47, so we can rewrite it as 3 to the power of 5 equals to 2 to the power of 3 mod 47. Let's move to another pair of powers that gives us something that is divisible by 47. M equals to 4 and n equals to 7. So 3 to the power of 4 minus 2 to the power of 7 is equal to 81 minus 128, which is equal to minus 47 minus 47 equals to 47 multiplied by minus 1, which is also divisible by 47. So we also can rewrite it as 3 to the power of 4 equals to 2 to the power of 7 mod 47. And we'll need here a theorem. So if we know that a1 equals b1 mod n and a2 equals b2 mod n at the same time, then a1 plus a2 equals b1 plus b2 mod n, a1 multiplied by a2 equals to b1 multiplied by b2 mod n, and a1 to the power of minus 1 equals to b1 to the power of minus 1 mod n. We can also say the same thing about the pair a2, b2. Now let's take 3 to the power of 4 equals to 2 to the power of 7 mod 47. And we'll use here our third property. So 3 to the power minus 4 equals to 2 to the power of minus 7 mod 47. Now let's take our another result. So 3 to the power of 5 equals to 2 to the power of 3 mod 47, and 3 to the power of minus 4 equals to 2 to the power of minus 7 mod 47. So we used our first equality and this last one. And we will use the property number 2. So 3 to the power of 5 multiplied by 3 to the power of minus 4 equals to 2 to the power of 3 multiplied by 2 to the power of minus 7 mod 47, which will give us that 3 is equal to 2 to the power of minus 4 mod 47. Now let's turn back to the condition of the task. We know that 3 to the power of m minus 2 to the power of n is divisible by 47. In our notation, we can rewrite it as 3 to the power of m minus 2 to the power of n equals 0 mod 47, which is the same as say that 3m equals 2 to the power of n mod 47. And now let's substitute our previous result into here. So we have a system 3 equals to 2 minus 4 mod 47, and 3 to the power of m equals to 2 to the power of n mod 47. And we can substitute this 3 into here, which will give us that 2 to the power minus 4m equals to 2n mod 47. And we can multiply both sides by 2 to the power of 4m. So 1 equals to 2 to the power of 4m plus n mod 47. Consequently, 2 to the power of 4m plus n equals to 1 mod 47. And now we have this strange number here, 4m plus n. And we also had it in the task, so we had 4m plus n, and now we find it. For our next step, we will need another theorem, which is called Fermat's little theorem. Fermat's little theorem. If we have a prime number, so if p is prime number, then for any integer number a, the number a to the power of p minus a is an integer multiple of p. An integer multiple of p. And in our notation, we can write it as a to the power of p equals a mod p. And this theorem is also equivalent to the statement that a to the power of p minus 1 is an integer multiple of p. Therefore, a to the power of p minus 1 equals to 1 mod p. So these are two equivalent statements. And why do we need it? We know that 47 is a prime number. So it's a prime number. So according to our Fermat's little theorem, we can say that 2 to the power of 47 minus 1 equals 1 mod 47, which means that 2 to the power of 46 equals 1 mod 47. And but in the task we have another number. We have 23 here. 23 here. And 23 is of course related to this power of 46. So maybe it will be interesting to check whether 2 to the power of 23 gives the same remainder of 1 mod 47. So let's check it. 2 to the power of 23 mod 47 equals to 2 to the power of 20 plus 3 mod 47 equals to 2 to the power of 20 multiplied by 2 to the power of 3 mod 47 equals to 2 to the power of 10 to the power of 2 multiplied by 2 to the power of 3 mod 47, which is equal to 1024 to the power of 2 multiplied by 8 mod 47. And we know the property that a squared mod n equals to a mod n multiplied by a mod n mod n. So 1024 mod 47 is equal to, it is equal to 37 mod 47, due to the fact that we can express this number as 21 multiplied by 47 plus 37. And this is also equal to minus 10 mod 47. And according to our property, it means that in our that here we have to write 100 multiplied by 8 mod 47 as this 1024 squared mod 47 will be equal to minus 10 squared mod 47. So this is 800 mod 47, which gives us just 1 mod 47. So we proved that 2 to the power of 23 equals 1 mod 47. The next question is, does there exist any number k that is lower than 23 such that 2 to the power of k equals 1 mod 47? So does there exist such number? The answer is no, but let's prove it. Assume that such number k exists, then once again k is less than 23 and 2 to the power of k equals 1 mod 47. But it means that all numbers like 2 to the power of 23 minus k, 2 to the power of 22 minus k, and so on, they have remainder 1 mod 47. Therefore, k k is a divisor of 23, or there exists another number, like let's name it k0, that is less than k, such that 2 to the power k0 equals 1 mod 47. However, we know that 23 is a prime number. So it's a prime number. So our k equals to 1 is the only one divisor that is lower than 23. And obviously 2 to the power of 1 will not give us this remainder of 1 mod 47. So this is a contradiction. Therefore 2 to the power of 23 is the minimal number such that 2 to the power of 23 equals 1 mod 47. So once again, what do we know? We know that 2 to the power of 23 equals 1 mod 47, and there doesn't exist k that is lower than 23, such that 2 to the power of k equals 1 mod 47. Yeah. And we also know, let me find it here, yeah, that 2 to the power 4m plus n equals 1 mod 47. So according to the logic we used in our proof, in this proof right here, 4m plus n is divisible by the minimal natural number k, such that 2 to the power of k equals 1 mod 47. And we proved that k is equal to 23. Consequently, 4m plus n 4m plus n is divisible by 23. Is divisible by 23, which means that the remainder of the division of 4m plus n by 23 is equal to 0. So the answer here is just 0.